Understanding Docker images. Every Docker container starts from an image. Images are the foundation of containerized applications. Understanding images is essential for Docker mastery. Images provide consistency and portability. Why Docker images matter. Containers are created from images. Images package applications and dependencies. Images ensure consistency across environments. Images simplify software deployment. What is a Docker image? A Docker image is a read-only template. Images are used to create containers. Images contain application requirements. Containers cannot exist without images. Image blueprint analogy. Image equals blueprint. Container equals building. One blueprint can create many buildings. One image can create many containers. What does an image contain? Application code. Runtime environment. Libraries. Dependencies. Configuration files. Why images improve consistency. Same environment everywhere. Eliminates dependency conflicts. Simplifies team collaboration. Reduces deployment failures. Image versus container recap. Docker image. Template. Read-only. Stored on disk. Docker container. Running instance. Executes applications. Created from images. Real-world example. Python application. Python runtime. Flask framework. Required libraries. Application source code. All packaged into a single image. Images are read-only. Images are immutable templates. Running containers do not modify images. Docker protects image consistency. Changes occur in container layers. Understanding immutability. Images remain unchanged. Containers can be recreated anytime. Consistent deployments become possible. Reliability improves significantly. Introduction to image layers. Docker images use a layered architecture. Each layer represents a change. Layers stack together to form an image. Docker reuses layers whenever possible. Typical image layers. Layer 1. Base operating system. Layer 2. Runtime installation. Layer 3. Package installation. Layer 4. Application code. Example layer structure. Ubuntu base layer. Python layer. Flask layer. Application layer. Configuration layer. Together they form a complete image. Benefits of layers. Faster downloads. Reduced storage usage. Efficient caching. Faster builds. Better performance. Layer reusability. Shared layers are stored once. Multiple images can reuse layers. Disk usage is reduced. Downloads become faster. Docker image IDs. Every image receives a unique ID. Docker uses IDs internally. IDs identify exact image versions. Names and tags map to image IDs. Example image ID. A1B2C3D4E5F6. Unique identifier. Generated by Docker. Used for image management. Understanding image names. Example. Jinx. Ubuntu. Redis. Python. Image names help identify repositories. What is a tag? Example. Jinx latest. Jinx. Repository name. Latest. Image tag. Why tags are important. Identify image versions. Support version management. Improve deployment control. Prevent unexpected upgrades. Version tag examples. Python 3.10. Python 3.11. Python 3.12. Node 20. MySQL 8.0. Understanding latest. Often points to the newest version. Convenient for learning environments. May change over time. Explicit versions are preferred in production. Viewing local images. Command. Docker images. Displays downloaded images. Shows image information. Information displayed. Repository. Tag. Image ID. Creation date. Image size. Sample Docker images output. Jinx. Ubuntu. Redis. MySQL. Python. Available images can create containers. Downloading images. Command. Docker pull Jinx. Downloads image from Docker Hub. Stores image locally. Where images come from. Docker Hub. Private registries. Enterprise registries. Internal build systems. Understanding image size. Images vary greatly in size. Some are very lightweight. Others may be several gigabytes. Smaller images deploy faster. Benefits of smaller images. Faster downloads. Reduced storage. Faster deployments. Better performance. Lower bandwidth usage. Popular official images. Jinx. Ubuntu. Redis. MySQL. Postgres. Node. Python. Real development workflow. Download image. Store locally. Create container. Run application. Deploy application. Image management best practices. Use official images. Use version tags. Keep images small. Remove unused images. Update images regularly. Common beginner mistakes. Confusing images and containers. Using latest for everything. Ignoring image size. Downloading unnecessary images. Key takeaways and lesson summary. Images are read-only templates. Containers are created from images. Docker uses layers for efficiency. Tags help manage versions. Images are the foundation of Docker deployments.